So this session is not similar to most of the sessions that you have seen today. This is more towards relational databases. It's titled The Developer versus the Relational Database, how to do it right. Okay, now we don't have much time, it's just a 30-minute session. So I'm going to do more of a summarized session. So just to start off, how many of you all are actual developers? Quite a few. Database developers? One. Okay, a database developer is not a database administrator. He's a developer who works exclusively or almost exclusively with databases. For database developers, any database administrators? Okay, so this is good. This is the kind of crowd that I like to see here. So I myself, I am not an application developer like you guys. I am neither a DBA, I am somewhere in between. So in my line of work, I have worked with databases for quite some time. Application developers like yourselves tend to hate databases. You don't like databases. Is that right? You all like databases? Yes, so there's no point of this session then. Okay, moving on, a little bit about myself. I'm a SQL Server MVP for the last 6 years. I work as a technical architect for Navantis. Though it says technical architect, most of the time I develop BI solutions. I have written one chapter in a book, so that's all I have published. So I just put that there so I could fill up the space over there. Right. Okay. So the agenda is this. Is Venkat around? Okay, if he is around, don't look at that. Best practices? Okay, just guidelines. Call it guidelines. Okay. Right. So this is my agenda. I'll talk a little bit about database design, a little bit about defensive programming, then a little bit about indexing considerations, documenting, and about utility objects. It will be an overview because we don't have much time, like I said. Okay, so to start off with, I know you cannot see this right towards the back, but at least if you can see this part, this is the definition of the table, or partial definition of the table. Okay, what is wrong with this picture? Is there anything wrong here? It's not normalized, okay, but there is a unique identifier there. Okay, so why I chose this session, the developer versus the relational database, is because I've seen in my line of work a lot of developers, they don't care much about the database. They love to do the application part of it, the business layer and the user interface layer. Okay, but the database, they just look at it as something where you just dump your data. Okay, there would be a primary key here and there, but there would be a lot of denormalized tables, a lot of junk data, and like you can see over there, there's lots and lots of null values. Okay, right. So if you're going to break it down little by little, this is what's wrong with it. Like it was pointed out, you don't have a key there. Why do you need to have a key? Yes, to uniquely identify a record, but we do have a unique identifier over here. But it is nullable, which means null values can go in. Okay. What else is wrong with having a unique identifier as a identifier? If you can see the data over there, you will see that the data is not in proper order. Yeah, so we don't know if there is indexes on this or not. Actually we do. We don't create. We prefer not to create clustered indexes on a nullable column, but non-clustered indexes we can. So one of the main reasons is that, like it was pointed out, there is no key there, a proper key to identify the record. Okay, you can make the unique identifier a not null field, and then you can apply a primary key on that, but still that field is going to be quite a large field. Okay. So when you perform operations like joins, okay, it's going to take more time. There would be a performance impact. We prefer when we have indexes or when we have primary keys to have smaller or narrower fields. Okay, and if you look at the actual data over there, the third and the fourth records have the same first name and last name, similar the same address over there and a similar address over there. So we have a record or two records which are almost the same. It could be the same person. It is the same person, in fact. We can argue it could be two people with the same name, but there are too much similarities when you look at the other fields as well. Okay, right. So in a situation like this, does the business who is running this, who owns this database, how will they identify this data when it pops up on their application, on the user interface? How would they identify each customer? They would try to identify a name, right? But usually, what should we have? A code, a customer code. Okay, we call that the natural key. Okay, so there is no natural key here to identify it uniquely in the business aspect of it. Okay, okay. Then we have a data type problem here. If you can look at this, all of these are variable character max. Do you know what's the maximum size of varchar max? How much it can store? No. Varchar max? 2 GB worth of data. Do you need to have 2 GB worth of data for address fields? No, right? Okay. And then again, over here, we are using n varchar. Do you know what that n stands for in front? Okay, so Unicode characters or Unicode fields, they take up 2 bytes per character to store. We usually use Unicode characters for languages like Japanese and Chinese, likewise. But for English names or English language names, we did not have n varchar because varchar would be enough. Okay, assuming that this is going to only store English names. So we are wasting space over here because varchar and char take up only 1 character per byte or 1 byte per character, whereas n varchar twice that amount. Okay, so we have not chosen the correct data types over there. Even for the primary key, an integer would be better. Okay, and an integer which is ordered, most probably best if you could use an identity field, an auto number. Okay, and then like somebody pointed out, it's not normalized. We have too many addresses over there. See, we've got 4 addresses, and this one defines 6 different addresses, 3 home addresses and 3 office addresses. Okay, that's too much. And then constraints. There are no constraints defined here. Constraints limit the type of data that you can put into each field, thereby having more correct data. This will allow data which is not suited for the business to be inside as well. Okay. And finally, naming conventions. If you look at the naming conventions, a developer who is going to use the database would have to keep on referring to the schema of the database whenever he's coding. Okay, if you look at it, you have f name, l name for first name and last name, and then you have cust underscore h underscore address 1. Okay, and then for the table name, it's tbl customer. We know it's a table, so don't put tbl in front. Okay, so if you could come up with a better naming convention, it would make the life of the programmer, the developer, much more easier. These are some of the problems that we see over here in this design. Okay, so how many of you all have designed tables similar to this? It's okay. Why do you design it? Why do you design it as such? Right. So what he says is, to get started off, we design a table just like that, so that we can just dump the data in, and then maybe later we could, refactor it. Maybe you could normalize it. Maybe you could change data types. But then we get busy developing. Okay, we make the application end of it much awesome. Then you don't have time for the database, and then it builds on top of that, and then finally we have a very good application on the front end, but the database sucks. Okay, right. So a better design of that table would be something like this. This is not the ultimate design, but this would be a better design. Okay, different people could come up with different designs. Okay, so do you have any questions here? So I'm just going to go into little bits and pieces of areas which developers find uninteresting or areas which are being ignored.
Unique ID is okay as a primary key, but at the same time it's good to have a unique ID identifier also for the main business objects like customers.
Okay.
What is your
Like from my experience, what I feel is having a very narrow field is easier for us when we perform joins and when we perform data centric operations.
I think why people say that is to have both for your main business objects.
Mhm.
One is in case you have to merge with of your database with some other database, let's say the two companies merges and you need to merge data.
Okay.
The other reason sometimes people say is now when you get it, for example, in a web application, you can actually have different domain objects in one single web application, one single web screen.
Okay.
Then if you have unique IDs, unique IDs for your business objects, it's easier for you to do queries and CSS selectors, etc. on your business objects. Just asked if that is a good practice.
The first point was excellent. What he said was, okay, let's say you have customers and you are using unique identifier to identify each customer, the primary key. Okay, let's say that we acquire another company and then we're getting all their customers into ours. Okay, if both the companies had used 1, 2, 3, 4 onwards as their primary key, how would we bring them all in here? Okay, if we had used unique identifiers, it would be awesome. You can just bring them in. That's a good point that you make. Okay, so I got somebody to talk without pleading.
It's not necessary that
Yeah.
databases will not have the same unique identifiers, right? I mean, it's two completely different database instances.
Yes.
Even if you use it, there might be.
If both databases were good, there are chances that a global unique identifier is going to be global unique.
Across two different companies? Inside your database, yes, but across two different companies, you can't make sure.
The GUID is based on not just the database, right? It's based on several other factors, including the employment at back address and things like that. So I think it's guaranteed to be unique globally, even across databases.
For all practical purposes, it is unique.
So,
For all practical purposes, in practice, it is unique. I mean, there could be theoretical instance where you can generate two GUID similar, but that I think the time and IP address, the network adapter, etc.
anything else that you'd like to share? This is the final output of this thing. Code is agile as we've been talking since morning. Okay, but the database is kind of brittle. Okay, so if you do a design and you store data in the database, right? When you are going to keep on changing it, you can change your code. Okay, you can come up with testing scenarios and you can keep on changing your code to make your code better. But at the same time, if you're going to apply that to the database also, you could run into problems because your database is going to have data in it. Okay, so the point of all this is when you are designing a database, try to make sure that your database is foolproof, or a database has the best design that you could possibly put in. Right. Moving on to something that we have been hearing from morning. So programming defensively on databases is something that I read up quite recently. To be honest, I wasn't writing any, when I do my database programming, I have not done any defensive programming. Okay, we just write it, and like Naresh explained, we just check, we don't do actual tests. We put in some values, okay, we get the desired output, okay, fine. Okay, but we don't actually code unit tests so that to make it fail. Okay, we think it's like everybody else, it's the queue-based business. Okay. So when we do defensive programming, there are 4 things that are set up as guidelines. First, that you need to define and understand the assumptions that you're putting into the piece of code, for example, a stored procedure or a function. Okay. You need to define assumptions, saying that under these are the assumptions that I'm making, and based on that assumptions am I writing the code. Okay. But of course, there could be implicit assumptions that can go in without you knowing because of the way you understand SQL. For example, how many of you all knew that the where clause, you have where clause and a condition and another condition. Okay. How does this conditions evaluate in SQL if you know a little bit of databases? Is it first condition and then the second condition gets evaluated by the database, or is it in some other order? SQL Server, at least SQL Server, I am not quite sure about other relational database management systems, but most of them are. The conditions, they evaluate in a random order. So we are not sure whether it's going first the first condition and then the second condition. It could be the second condition first. So we don't know. Okay. So if you have written conditions in such a way where you might think if the first condition runs and then the second condition evaluates, the code will run fine. Okay. But if you run it the other way around, if SQL Server runs the second evaluates the second condition first, it may crash sometimes. Okay. If I have time, I will show you a code which demonstrates this. Okay. So what you can do is modularize your code as much as possible. So when you have a stored procedure, when you do some checking, or let's say you're doing some business logic, try to have some functions inside, or some more you can have nested stored procedures within that. So modularize it as much as you can and make it testable and test each of those modules as well, just like you would do in your application development. Okay, and then try to create test cases and create test cases that would also make it fail. Okay, and then try to reuse when possible, but there are lots of cases in SQL where you cannot reuse code. Okay, so be careful when you take some care when you reuse code. Okay, because you cannot say if there's a stored procedure and there is a chunk of it which some really awesome logic that you have written, you cannot just take it out and put it into another stored procedure, because you have not tested that little part of it. Maybe if you have tested the entire stored procedure, you can use that stored procedure somewhere else. Okay. So you need to take care when reusing. Fine. Next, indexing. Okay. Why do we use indexing? For performance. Okay. So usually what we do is when you create a table, we usually go for a clustered index, and the clustered index is usually created on the primary key. So that's a best practice that we usually do, but it will not work all the time. Okay. But when we are choosing a clustered index, you need to make sure that it's unique and it's narrow as possible and it's static. Static means you should not use a field which keeps on changing, the values keep on changing. Don't use such a field for a primary key or for a clustered index. Okay. Because a clustered index is going to restructure a table physically. Okay. And then all the other indexes that you're going to create, all the other non-clustered indexes that you're going to create are going to use this clustered index. Okay, so if you're going to have values changing in a clustered index, you're going to get fragmented data. The storage of those indexes are going to get fragmented, and then it's going to be slow. You're going to have a performance impact. Okay. Small tables, for example, tables with let's say 100 records, 1000 records. Sometimes it's better left just as it is. You need not create a clustered index. Even if you create a clustered index, most probably the SQL optimizer would not use that index. It would just do a scan of the entire table and not use an index at all. Okay, so small tables, just leave them alone. And then when you create your non-clustered indexes, choose fields which are used in the where condition and which are used in joins. Don't try creating indexes on all the tables. I have seen that they create a table with 15 fields, and on each field you have an index. What would that do? It's just going to increase the amount of disk space that's going to be taken up, and most of those indexes won't be used anyway. Okay, so choose the indexes wisely, and it is perfectly all right if you don't create your non-clustered indexes when you create your tables. Create your tables, populate them with data, let your application run, and then when you see some queries performing badly, then go and look at those queries and then try to create the indexes to tune your queries. Okay. That's why I say create indexes based on usage. Okay. And then you can consider included indexes. Has anybody heard of included indexes? Okay, an included index is like say you create an index on a particular column, let's say customer code, and then you can using the include keyword you can include more fields like the first name and the last name and the age and whatnot. These fields will not be used in the index sorting. It will not be used in index evaluation. Only the key that is used in index evaluation will be evaluated, let's say for example in a where condition or in a join. But when you select data, the first name, last name and all that, it does not go to the clustered index or the table and get the data. It takes it from that index itself. That's an included index. Okay. And then you can also use filtered indexes where you can create an index for a subset of your table. Let's say a subset of your table is always used and the rest of the table is not used much in your querying. You can create an index only for that subset using a where condition. Let's say where a particular field is not null, you only use that predicate quite most often, then you can create an index only for that set of data. Okay, so these are some of the ways in which you can use indexes to speed up queries. Okay. And then some utility objects. Utility objects are tables, maybe stored procedures which help you with your development. One of the most common and famous one is the numbers table. It is nothing but one table with one field of integer data type, and it has values from 1 to 100 or 1 to 1000 or 1 to 10,000 or 1 to million, just a sequence of numbers. Okay. It comes in very useful for all those different scenarios. Okay. For example, let's say you want to do string sorting. We have a string, okay, and you want to sort through that and put it in a particular order. Okay. You need not write a loop in SQL. A loop in SQL is takes up too much of performance. Okay. It does not give good performance at all. But when you use a numbers table, you have a whole set of data, a set of numbers. Using that, you could do your sorting very quickly. Okay. Or let's say you have a few dates with gaps in between, but you need to create a report with all the different dates, okay, a whole list of dates, but you don't have anything to fill up those gaps. You can use a numbers table. Okay, so you can use it for various amounts of purposes where you want some quick sets of data. Okay. And finally, documenting your code. How many of you like documenting your C# code? Okay, I'm sure that you're not going to like documenting your SQL code. Okay, your SQL code itself is going to look like this, lines this way and lines this way. At least in C# you have lines like this. You don't have going towards your right. Okay, but you need to document your code because sooner or later there's going to be somebody who's going to maintain your code. Okay, they need to keep it documented. Some of the simple ways of documenting is just indent and refactor your data, your queries. Let's say you have a stored procedure about say 1000 lines long. Instead of making it this way, break it down so that at least it looks nice, so that the person who is reading it can at least understand how the selects go and what are the conditions and where the joins happen. Because if it's in one whole line, it's quite difficult for the person to read the query. Okay. And also, when you actually document it using comments, don't just document what it does, what each segment does. Document why that has been written as well. Say you have written a code where you write a little where condition or a join. Just document why the join was done. Okay, that way the person who is going to read it and who is going to maintain your code will have a fair idea as to what your code is actually doing. Okay. Right. So these are some of the pain points that I've seen in database development, especially by application developers. So I'm sorry that I had to rush through the whole thing because we just had 30 minutes. So these slides will be shared. So I don't think we have time for a demo right now. We have 3 more minutes, 0 minutes. Okay. So any questions I will take during the break. There's a break of 10 minutes, I think. Thank you very much.